Society today faces a number of daunting challenges. At Infineon, we strive to address these challenges with technologies to make life safer, greener, and smarter. Joining us today are some of the leading industry experts who are at the forefront of technology development for self-driving cars.
Pretty much everything across the board is challenging. There's no slam dunks, but I think probably the two major pieces of this that make the problem so challenging is scalability and validation. It's very, very challenging to have all of the technologies that are needed in a fully autonomous vehicle so that you can deploy something like this at a massive scale. The other variant of scalability is validation. As you grow your operational design domain where you're going to be releasing this functionality and where you expect it to work, knowing when you've reached the right amount of validation that you can stand behind the product is an enormous challenge just by itself.
It's a software challenge, and the software consists of gathering the data from all onboard hardware sensors, and the second portion is allowing the car to make a reliable decision in all operating conditions. I'll give you a simple example. If you have a car coming out of a parking lot, it needs to take into consideration all the pedestrians, all the bikes on the road, all the cars, and even the object that's coming from around the corner.
The industry has been waiting for a lot of the sensing technologies that are finally becoming available. It's not until now that we've really had access to the amount of megapixel cameras, the advancements in LiDAR, both in terms of the tech itself as well as the price point is finally reaching critical mass where it's becoming realistic.
I think incremental improvement, I think all the building blocks are there. It's just the way how you consistently improve based on learning from all these scenarios and also from all these operating conditions.
We're adding a lot of complexity, a lot of hardware. It's definitely going to take power to operate a system like this, so the efficiency will decrease, but we've done the math and we definitely think the benefits of autonomous driving outweigh the additional impact of the cost.
So when the car is able to detect objects beyond 300 meters accurately and precisely in all weather conditions, it allows the other sensors on board to focus in those regions of interest instead of continuously scanning and analyzing the scenes, which takes time and power. So when you have a radar, a high-performance radar that enables the car, give the car this type of capabilities, it will overall reduce the power consumption of the car.
NIO is an electric vehicle company. We have two products in the market right now. It's called ES8 and ES6. It's a 7-seater and a 5-seater SUV, respectively. Our team, we're responsible for not only the Level 4 autonomous driving program, which is still in development, but we also developed the ADAS system. We call it NIO Pilot. That's something that we can realize immediately, start to bring value to our users. Vehicles are also a very valid source of information that we can use in the design and deployment and development of our Level 4 system.
Metawave is building high-performance radar for highly automated vehicular operations by detecting cars beyond 300 meters, pedestrians beyond 200 meters, separating objects at these long distances in adverse weather conditions. We do that by focusing the beam in a very narrow cone and scanning it in a two-dimensional directions continuously based on these detections. Augmented with that, of course, we have the system-level algorithms and the AI, the object classification AI. So we do that using our own front-end analog integrated circuits with the antenna arrays and a single transceiver from Infineon.